So you think that you have a theory.
I have a theory too.
Yeah? What is it?
I have a theory.
I got the movie.
I have a theory.
You know, it's just a theory.
I have a theory.
No. What you have is a hypothesis, which is still an important part of the scientific process, but there's a lot of confusion about what a hypothesis is, what a theory is, and what the scientific method is. So let's get into it. Now, in my experience, the best science starts with, hey, that's weird, and that's your observation, which leads to your question, why is it weird, or how is it weird? And that leads to your scientific hypothesis, which is the explanation for the question. It is the reason why the things are happening. And that leads you to your predictions. Your prediction works like this. If X happens, then I would expect Y to happen because of Z. And that because of Z is your hypothesis. The if-then is just your prediction. And that then leads to your statistical hypotheses and your statistical analyses, which are too complicated to get into now, and then your decision. That decision then can feed into a larger theory, which is a carefully thought out explanation for many observations in the natural world and using the scientific method and brings together many facts and hypotheses. So the theory then feeds into observations and vice versa. Take, for example, gravity. We know if you drop something, it falls. We know the rate at which it falls. We know things are being pulled in. But the how and the why that's happening is the theory of gravity. Similarly, evolution by natural selection explains how adaptations occur and why adaptations occur, and answers questions about the fossil record, and also answers how all of these species relate to one another. Now let's take the scientific method of hypotheses and predictions and apply it to a real-world example of ants. So, as you probably know, ants, when they find food, tend to leave a scent trail. So when they leave the food, they can find their way back to it, or tell other ants how to get there. But in a desert scenario, wind will come along and blow the scent trail away. So this gives us the question, what's a poor ant to do? How do they find the food when there's no scent? The answer, the hypothesis, ants can count. Sort of. More like an internal pedometer. So to test this, scientists took ants that knew where food was and then either shortened their legs, kept their legs the same length, or lengthened their legs with stilts. And if you're curious what that looks like, it looks like this. And in a perfect example of predictions going right, they found that ants with normal legs could find their way to the food, while ants with stumpy legs took the same number of steps, but came up short. While ants with stilts took the same number of steps and kept going. So there you have it. Ants can count. In a previous video I showed how bees can count. I don't know when my content became all about animals counting, but I hope you enjoyed this and learned something.